Good morning, students. Today we discuss the dependency preservation. Let's take an example. Here R is the relation with the attributes A, B, C, D, E, and R1 and R2 are the two sub-relation consist of R1 B, C, D and R2 A, C, E with the functional dependency set F is equal to A, B arrow C, C arrow E, B arrow D and E arrow A. To find the dependency preservation, at first we check for all the functional dependency. If all functional dependency in the set of functional dependency is preserved, then we can only say that F is preserved. Otherwise, if any functional dependency is not preserved in that subschema, then we say that the set of functional dependency F is not preserved. So let's start how we find the dependency preservation. Now we check for the functional dependency AB arrow C. Let Z will be the left hand side of the functional dependency AB arrow C. That will be AB. Now we find Z intersection R1. That we get only B. Then we find the closure of that value, B closure. For B closure we get B and D. Okay, that is BD for writing simple. Okay, now whatever we get, that will be BD intersection R1. We find that value. Again that value will be BD. Now Z becomes Z union BD, this value. So AB union BD, so that will be ABD. Okay, now Z, whatever the value of Z, that does not contain all the attributes of the functional dependency AB arrow C. So again we check for the second relation R2. Now Z intersection R2, that will be our Z will be ABD. So ABD intersection R2 means ACE. So that will be A, and we find the closure of this. So according this, A closure will be A. Now whatever the value we get, we just intersection with R2. So that will be A, and Z will be Z union A, that will be ABD union A, so that will be ABD. Okay, so we start with Z will be AB, and now our Z will be ABD after complete the R1 and R2 checking. Again it will be does not contain all the attributes of AB arrow C, and its value changes its value. So again we check for the first relation again. So Z intersection R1, that will be we get BD, and we find the BD closure. So BD closure will be we get BD. So therefore BD intersection R1, and we get BD, as well as Z will be Z union BD, and that gives ABD. So no changes in Z. So we say that since Z does not contain the all attributes of AB arrow C, and retain its value, so we say that AB arrow C is not preserved. In functional dependency F, one functional dependency A, B or C is not preserved, so we say that F is not preserved. Okay. Now for practice, we check for the another functional dependency. Now we check for C arrow E, whether C arrow E is preserved or not. Again, let Z will be the left hand side of the functional dependency C arrow E, that will be C. Now Z intersection R1, that we get C intersection BCD, so we get C. We find the closure of C. Initially the closure of C will be CE. Again CE intersection R1, that we get C, and Z is equal to Z union C, so that will be C. Now Z will be C. Now we check for the R2. So Z intersection R2, that is equals to again C, and we find the closure of C, that will be CE, and CE intersection R2, that will be CE, and Z is equal to Z union CE is equal to CE. Since Z contains all the attribute of functional dependency C arrow E, therefore we say that C arrow E is preserved. Now we check for the functional dependency B arrow D. Again Z will be B, the left hand side of the functional dependency. Now we find the Z intersection R1, so that will be B, and we find the closure of B, so that will be BD, and BD intersection R1, that will be BD. Okay, as R1 is BCD, so therefore Z is equal to Z union BD, that will be BD. Okay, and since Z contains all the attributes of functional dependency B arrow D, therefore B arrow D is preserved. Okay. Now we check for E arrow A. So again we start Z as E, the left hand side of the functional dependency E arrow A. Now we find Z intersection R1. So that will be E intersection BCD is equal to phi, and the closure of phi, that will be equals to phi. So phi intersection R1, that will be phi, and Z is equal to Z in union Z union phi, that will be Z is equal to E. Now we check for the R2. Now Z intersection R2, that is equal to E intersection ACE, so that will be E, and we find the closure of E will be EA. Now EA intersection R2, that will be EA, and Z union EA is equal to EA. Since Z contains all the attribute of functional dependency E arrow A, therefore we say that E arrow A is preserved. So in this example, AB arrow C, this functional dependency is not preserved. C arrow E is preserved, B arrow D is preserved, E arrow A is preserved, but the set of functional dependency F is not preserved as AB arrow C is not preserved. If we find that AB arrow C is not preserved, we don't continue for the functional dependency C arrow E, B arrow D, E arrow A or other functional dependency. We just stop when one functional dependency is not preserved. For simple, if we want to know whether this set of functional dependency is preserved or not, if we check for all functional dependency, if all the functional dependency attributes is present in a specific sub relation R1, R2, Rn, then we say that that dependency is preserved. Okay. Now again we just recontinue. At first we check for the AB arrow C. We just assume the left hand side of that functional dependency AB as Z, and we find the intersection of Z and R1. Then we calculate the closure of that particular value. Whatever we get, that value intersection with R1 again. Whatever we get, and then Z will be the union with that value. Okay. If we get all the attributes present in the relation, then we stop, otherwise we continue for the next sub relation. Again Z intersection R2 we find, whatever the value we get, find the closure, and again that value intersection with R2 get, and the Z will be union this, and this process will continue if until Z will be changes its value or Z gets all the attributes. If Z gets all the attributes of a specific functional dependency, then we say that that specific functional dependency is preserved, otherwise it will be not preserved. Similarly, we calculate C arrow E, here Z is equal to C, Z intersection R1, so that will be C intersection BCD, so that will be C. We find the closure of C, that is CE. Again CE intersection R1 is C, so Z will be C. Now Z intersection R2, that will be again C and ACE, we get the value C. We find the closure of C closure, that will be CE, and C intersection R2 will be CE, and Z becomes CE. Now in this case Z contains all the attributes present in functional dependency C arrow E. So we say that Z is preserved or C arrow E is preserved. Now for this functional dependency B arrow D, again we start the left hand side B for Z. We calculate Z intersection R1, so that will be the B. So we find the closure B closure BD. Again BD intersection R1, that will be the BD, and Z becomes BD. And Z contains all the attributes of the functional dependency B arrow D. So we stop here and we say that B arrow D is preserved. Now for functional dependency E arrow A, we start with the left hand side of the function dependency E arrow A, that is Z is equal to E. Then we intersection with the R1, we get null value, so Z will be E. Now again we start with the sub relation R2, and we get the intersection of E and R2, that will be E, and we find the closure E closure, that we get EA. And again EA intersection R2, we get the EA, and that from we get Z as Z is equal to EA. and Z contains all the attributes of the functional dependency Y E arrow A. So we say that E arrow A is preserved. Thank you.